Am I the only person excited? Yeah, okay. So let's welcome Haoqi.
So I'm just gonna take my audio down because I could hear Luis talking through my computer. It's a little creepy if it's myself, but Luis is great. It's really good to hear about that. So I just yeah, welcome and thank you all for coming. I guess the first thing first confession is that I accepted this talk invitation on the false premise. I thought I was invited to announce the speaker for this talk, and I said yes, and then Alana was like, no, I want you to give the talk. I'm like, oh really? And no, so I you know, and it's a little weird because it's in a way a talk that I was giving before my sabbatical, or sorry, before I got tenure, but also before my sabbatical, and I'm kind of in between projects right now, so I wasn't sure if I really wanted to give the same talk, but it actually gave me an opportunity to really reflect on how my thinking has changed and in what ways it hasn't changed. I'm a little afraid that some of what I'm saying will just be preaching to the choir. Yeah, because it's just like, yeah, of course, we need to think about complex systems and stuff like that. But I think there are some wrinkles or textures that I hope to get into that I hope is insightful or at least useful to talk about together. Okay. But yeah, I mean, I think another thing I want to say is just I started working, kind of all my work is really a struggle of me not coming to terms with my work. Okay, so it's this struggle where I'm trying to align my values and things that I care about with the work that I do. And I think in some ways, this is kind of the culmination of how that search for alignment between my values and my work has gone. And my goal for this talk isn't so much that you walk out of here sharing my values, that'd be kind of boring, but that the talk maybe inspires you to think a little bit about your values and how to achieve them, reach them, and advance them, okay? So with that, I wanna share with you some thoughts on what I call computational ecosystems and what I think they could do for advancing human values at scale. So I want to start with this question that, as I come to learn more about my work, just keeps coming up, okay? And it's a really annoying question for technologists, and I'll explain why in a second. How can we create scalable solutions to human problems and advance desired human values in the absence of a technology that can overcome real-world constraints, right? So it's just like a really unfortunate question if you're a computer scientist or a technologist to be asking, because the whole premise is that we can't actually do this with technology, at least alone. Okay, so let me give you an example of what this looks like. So I came to Northwestern probably 2013. I started this program called Design, Technology, and Research, where I work with undergrads and grad students on research. Okay, and we started with just 7 people, this little community, and within a quarter, we were about 20 people. So I was mentoring 20 students, and I very quickly learned a very basic fact about faculty life, which is that my time doesn't scale. Okay, I was up till 2 in the morning most nights, just talking to students and trying to be like, okay, for your project, here's some things to think about. For your project, I was getting exhausted, and I wasn't really doing that good of a job as an advisor anyway, right? So it just doesn't scale. So what can we do about this problem? Well, first of all, right, what is the problem? The problem is, how can a single faculty mentor train 20+ students, okay, so scaling some kind of solution, right, to cultivate self-directed learners and to build new knowledge, right? These are the human values that we cared about, that we really wanted these students not just to be doing some stuff, but we wanted them to be driving the projects and learning how to self-direct, but also build new knowledge, right? We don't want them just to self-direct and produce nothing. We also want them to actually be thinking about creating new knowledge. But in an absence of a technology that scales mentor time, right, being the real world constraint. And the unfortunate thing on the human side is that the best human solution, which is very effective, it just doesn't scale very well, okay? So the best human solution that we know is called apprenticeship, right? Just one-on-one mentoring, right? And it's really effective for learning a whole bunch of complex skills. But unfortunately, as Collins reminds us, apprenticeship requires a really small teacher to learner ratio that is just not realistic, he argues, in the large educational system of modern economies, right? So bummer. But what about machines? Right? So what about the best machine solution? But well, the problem here is that there isn't really an AI technology that can replace Luis and I yet. Okay, and maybe never, but maybe in the future. Who knows? Okay, and well, why is this hard? So just to kind of talk about it a little bit, because I want us to build this intuition about when we say the machine can't do something, why? Right? So just to get us to keep thinking about that intuition. Well, here, you could have software that provides useful prompts to guide student thinking. You could also have kind of software that creates or brings out the content or shows the content, whatever. But there's nothing that could really model this research process and also model the way of instruction that a faculty member would kind of offer to a student as a mentor. Right? And those are the kind of things we don't know how to do with a computer. So then the question is, well, what do we do, right? So you could wait for a technological silver bullet, but that could take some time, or maybe it never come. Maybe there isn't a way to do it with AI. We could compromise in a whole variety of ways, right? So we could scale lecture, like forget undergrad research. Let's just do MOOCs. Right? Let's just scale lecture. We could train a very small set of elite students, which is what most of us end up doing. And the undergrads kind of get just relegated to root work, right? They'll code up some stuff or transcribe some interviews, but we're not going to have them do anything serious, right? But none of these things really provide the same learning benefits as the kind of self-direction that we're looking to cultivate. So then what can we do? Okay, and this is what over the last 8 years this general question has gotten us to think about what I call computational ecosystems. And what computational ecosystems are is that they interweave community processes, social structures, and interactions together with intelligent systems to really get humans and machines to come together to solve larger problems. Okay. Now you're saying, well, yeah, that makes all the sense in the world, but that's just a socio-technical system. And my argument is, yes, exactly, that's a socio-technical system. But my argument is going to be that while this has many components, typically we don't actually design those components all together. And what I'm going to argue for is for designing the ecosystem as a whole and how we go about thinking about that problem. And this focus on a systems approach to design echoes calls from people like Atul Gawande, right, who just argues that having great components is not enough. He's a medical doctor, but he argues that we've been obsessed in medicine with components. We want the best drugs, the best technologies, the best specialists, but we don't think too much about how it all comes together. It's a terrible design strategy, actually. And he goes on to say that making systems work is the great task of our generation of physicians and scientists. I'll go further to say that making systems work, whether it's in healthcare, education, climate change, and making a pathway out of poverty, is the great task of our generation as a whole. Okay. And this kind of call for systems level thinking has also been echoed by folks in AI. So this is Eric Horvitz, who is the director of Microsoft Research. And he says, I'm pretty sure that the next leaps in AI will come from integrative systems rather than wedges. We need to focus on building a system where the whole is greater than the parts. Okay. And closer to my home field in human-computer interaction, or HCI, there's also been similar calls. So this is George Furness, who argues that it's likely that our designs will be more successful if we become more mindful of this larger picture, this mosaic of responsive adaptive systems in which our designs are embedded. Right? And I think we would be really wise to heed George's words here. And I think most people here probably wouldn't disagree with this idea that we have to be mindful of the overarching system. But my argument is that we actually have to go further than just being mindful of the larger system. I'm going to argue that we actually need to design the whole system, expanding out. Okay, so here's really what I'm talking about. So to design the entire system, I'm going to take a socio-technical approach, as you might imagine, but I'm going to extend it to think about how do we account for the added complexity of designing the system as a whole. Okay, so one of the first things I want to kind of share along with that is that even though we often talk about complex socio-technical systems, most of them are actually just designed component by component or layer by layer. Okay, so typically, for example, we might work on a new great collaboration tool for a group of people to do something, right? Or we might design a new coordination mechanism for a crowd of people to contribute some information. I don't know, some kind of prediction market, some other thing, okay? But really what I'm asking is for us to think about, with the computational ecosystem approach, what if we can bring multiple structures of groups, crowds, individuals all together and think about designing ways that these different interactions might reveal certain synergies that allows us to do things where designing for any individual configuration wouldn't really give us. And as another example, we often design layer by layer. Okay, so first we design a community process of how our organization is going to work. We introduce all kinds of social structures that allow us to work in that way. And then we add on tools that help us do that kind of thing. Right? And in reality, actually, it's not even as pretty as this. Often you go into an organization, you adopt, or more like, there's a set of legacy of this that you kind of just take on, and then you maybe create a tool on top of it, right? So even in places that you think might be forward-looking, so as an example, maybe Google, when they introduce new tools, they kind of end up having to follow the same processes, right? The processes kind of are fixed, and you just get to design the tools for the current processes. But the question I'm asking is, well, what if we do get to design really a whole slice of this at once, right? What if we do get to remove this constraint and think about designing the processes, social structures, and tools that radically reconfigure how we do something? What kind of power can we get, and what kind of problems can we solve that we couldn't without that kind of reconfiguration and redesign at the ecosystem level? Okay, so really what I'm arguing for is that these computational ecosystems are systems, but they're designed as integrative solutions. Okay, and the thing I'm interested in is designing simultaneously all these components and thinking about the people and the technology as well, but taking this more comprehensive approach, constructing the parts and how the parts interact, both technically and people-wise as well. Okay, and to demonstrate to you, why this argument works or why it's important, I want to first share kind of these two ways of thinking that we're going to need as we go about doing this, right? So one of the ways of thinking is what we call computational thinking, and many of you are familiar with that, just thinking about competencies, thinking about ways of abstraction, problem solving. But I want to extend that idea to really thinking about people, machines across the whole ecosystem, right? So often we think about computational thinking as just designing the computer algorithms where a human and the computer in pairs. But I want us to think about many, many softwares, many, many systems, many, many people in different configurations, all of that working together, how to think computationally about those competencies and those distributions of abilities and tasks and so on as a whole. Okay, and the second idea is ecological thinking, which is to really embrace this idea that humans and these systems that we create are going to be embedded in an ecology where we want those ecologies to be sustainable, those ecosystems to be sustainable, and we want the interactions that are happening to actually support the ecosystem members and the proper functioning of the ecosystem. So the ecosystem continues to allow it to do what it should do. Okay. And to show this, I'm going to show you two examples, one from community-based planning and another from research training, the question we started with. Okay, and then I'll preview a little bit what's next for computational ecosystems, some of the things that my students are working on right now, some of them in the audience. And then lastly, I do want to spend a few minutes just talking about what I now think to be the limited role that technology can play in advancing human values. Okay, so I'll get to that, but any questions so far? Is everyone with me? Am I just preaching to the choir? Yeah. Okay. All right. Yeah. Any questions? Yeah. Yeah, I think it's a great question. Maybe this is something we could kind of come back to later too. But the question is kind of this idea that, well, I think just I mean, it's such a great question, right? I didn't know if I want to talk about it in this talk, but when I gave this talk years ago, ecosystem, like people weren't really talking that much about ecosystems. Now, if you go to Google, you go to any of these tech companies, the first thing they say is, we have a great ecosystem. What they want to say is, we created everything you ever need in your life. Stay with us. Don't go talk to anyone else, right? So yeah, I think monopoly power and markets and the ability for marketplaces and platforms to kind of set positively, generate buy-in, but in other ways, kind of maybe abuse or at times at least use their monopoly power is definitely something, right? And there are going to be questions about privacy as well. So I don't think I'm going to address any of those explicitly today, thinking in more kind of benevolent terms, at least through my examples, but I think it's a factor. And I think it's also a question of, if we have all these values that can come out of an ecosystem, then how do we think about competing ecosystems, or how do we navigate in the larger system, right? So I think those are good questions. I'm not sure if I have good answers, but we could certainly talk about them more later. Yeah.
So in my case, almost every sentence that so far that started the discussion.
Yeah.
I didn't interrupt with anything so far.
Yeah.
I wanted to see where you are going. But since you are asking for a question, one of the things that was very striking to me, one example is this concept of having best optimal great solution for the components, which is actually a very unbiological statement. Right? So when you think about the biology, almost everything is really crafty and sloppy. Right? We have a bunch of cells that are very poor oscillators in isolation control our heart rate. But then when you put a bunch of them together, they actually can synchronize together.
Yeah.
And each one of them is. And so the solution tends to be about more about the process that is flexible and that kind of allows for interaction as opposed to having beautiful things.
Yeah.
But so to what point are you thinking about one of these things?
Yeah. Well, I'll show you my solutions. And if you're a computer scientist or just somebody who's interested in optimization and perfection, I will disappoint you to the maximal degree, because I think part of it is to show that no, not all the components need to be perfect, but they need to fit. Right. So I think I'm going to give you some examples of the fit and how designing for fit gives you a lot of power. And the algorithms that I'll use, and I'll show you some of the algorithms. The algorithms themselves, are pretty basic in some ways. Okay, so I think that's a great point. And I think another thing that I'll get to later, and maybe I'll move on after this comment, but the not only are the biological systems kind of as you described, I think there's also a weird way in which we could get overly amused with computational power in a way that ultimately just doesn't serve us, not only for this kind of efficiency and the creation of the system, but maybe for what we want in the first place. Okay, and that's a point I'd like to get to later in my talk as well. So it's a great comment. Okay, so I'll move on a little bit, and just feel free to interrupt as you have questions or things that you are compelled to kind of ask or talk about. Okay, so I want to start by talking a little bit about community-informed planning, and really the goal here is to create an inclusive process that scales and that advances the goals of its members as we plan something together. Okay, and the example I'm going to use is planning academic conferences. Okay, so what I'm showing you here is a photo of the ACs, or what they call the associate chairs of CHI. It's the big HCI conference. Okay, planning the schedule for CHI. CHI is a 4-day conference. There's normally about 16 simultaneous sessions, lots of papers, lots of content, lots of attendees, about 3,000 attendees, I think 1,000 papers or something like that. But there's other content as well, okay? This is how they plan the schedule, or how they used to plan the schedule before we came along, okay? So they spent 2 days, in a room together where on paper, this is a session, each of these is a paper, and they're literally creating these sessions and moving them around to create the schedule, okay? And if this isn't horrific enough, as you're seeing it, and how much effort this takes, when the chairs go home, they take this paper schedule, they take a lot of pictures of it, they bring it home. They then spend 100 hours fixing the conflicts that are embedded in the schedule. Okay, what kind of conflicts? For example, they have the same person presenting in 2 places at once. They have you being interested in complex systems and also networks, but those 2 sessions at the same time, so you can't go to both of them, right? They have all kinds of other things that are just really complicated, right, to address everyone's preferences, but also that they need to think about as organizers for the conference. And it's painful, and the schedules are not that good, is the other problem, okay? So the challenge for organizers is really twofold, right? And on one hand, it's an informational challenge. They don't know about the diverse preferences, constraints, and knowledge that these community members actually have, right? You don't know what all these attendees want. You don't know what all these authors want. But furthermore, you lack tools for really managing the complexity of the schedule. Right? There's got to be better ways to think about scheduling. So our solution is called COBE. It's a computational ecosystem for a process we call community-informed planning. Okay, and it just has 2 simple ideas. One, engage the whole community in planning. The second idea, give organizers tools that allow them to manage the complexity of the planning and to resolve conflicts, right? So these ideas are actually really simple, but the real question is, well, how do you do this? And how do you do this in an effective way? And here's where we're going to see that thinking about the ecosystem as a whole is going to give us some power, okay? So the first idea is that we're going to engage the entire community in planning. So we have designed these different processes to learn about people's preferences and the knowledge that they have about the content that's at the conference. So we engage committee members to make initial sessions after the PC meeting or the program chair meeting. And then we also ask authors to tell us which papers they think fit in a session with theirs, right? And what are the papers or content that they like to see. We then help attendees navigate the schedule by creating this recommendation system where we recommend papers and sessions. And we use their favorites, so the ones that they mark as their favorites, to identify popular sessions and talks of mutual interest that need to be maybe put at different times and different spaces, okay? And to do this, right, we are already, as you can see, engaging different crowds and groups of people to collect this information. But we're actually a little smarter than that. So we adopt this process we call incentive chaining, okay? And the way it works is that we're thinking about how to engage increasing sets of ecosystem members by using the data collected in the earlier interactions to make the later interactions better for the people who are contributing data, but also so we could collect better data. Okay, so how does this work? So for example, the expert categories that are generated in the PC meeting, so that's all the way on the left, right, going to the right, we couple that with a computer algorithm, just TF-IDF, right, it's just kind of topic similarities. And we create that list of recommendations of similar papers, a short list for authors. And it turns out in our studies that the recommendations are a lot better than if you just use the machine algorithm. And of course they are, because we're giving them the expert categories and using that information to essentially create the short list of papers that we ask authors to review, right? So they don't have to review 400 papers from the whole conference or however many to find the ones that are relevant. But then we take the data that the authors give us, which is about 10,000 different affinities of different papers they think are related, and we use that as a seed to our recommendation engine for attendees. And what that does is it avoids the code start problem in collaborative filtering, where basically what happens is you normally have to like a whole bunch of stuff before you get good recommendations, because there's a dearth of data about what your interests are, right? But because we have that data, we're able to give you good recommendations right off the bat, right? So you could find the sessions that you're interested in way quicker, and then when you tell us your favorites, it's from that set, and it allows us to more quickly learn about your interests, so that we could know what the popular sessions are and so on. Okay. Right, so again, this idea, right, really thinking about how different interactions can be chained together to produce a better outcome. Okay, so once you have this, for those of you who are optimization inclined, the obvious answer is you take all this preference information and all this constraints and stuff that you collected, and you feed it into an optimizer, right? No, we're not going to do that. Okay, we're not going to do that. And why are we not going to do that? Well, we're not going to do that because actually this problem is still highly underspecified. Right? So even though we collected all this data, it turns out there's a lot that we don't know about what papers shouldn't, for example, go together. And if we just do the optimization, we're going to create some kind of schedule that respects the constraints that we told it about and the preferences we told it about, but it'll violate a whole bunch of others. And the problem is that when the organizer then goes into this big schedule that got created by this optimizer, they don't know where the problems are, right? So it's hard for them to go and fix it and apply their knowledge into the schedule. The other thing is that the organizers actually have different things that they care about in addition to these constraints, right? They have to make sure the sessions are thematic. They have to make sure sponsors get certain slots. They have all these other things, some of which are really hard to encode into the optimization. But those are important. And basically to just say, let's just optimize it is basically a non-starter for most of the people, organizers who actually organize these conferences. Because the problem is, it's not the only problem. They also have to plan the schedule according to a bunch of other things. Okay, so here's the solution we came up with. And the idea is something we call a community-informed mixed initiative interface. And what this interface does, it's an interface for organizers. It puts them in the driver's seat and gives them a holistic view of the constraints and preferences from the entire community. Okay, so let me show you how this works. So first of all, they get a multi-dimensional view of the schedule. So they can look at the schedule across all these different kinds of view options that they have. And when they go into a session, these red dots show how many conflicts there are with that session. So they could click that, propose a move. And what the system shows them is all the other places that if they swap this session with that other session would reduce the number of conflicts that the system knows about, right? So it doesn't just make the swap because there could be other conflicts or other things that the organizers are thinking about, but it provides suggestions based on what it knows. And it leaves the organizers still in charge to apply their tacit knowledge and other goals that they have. Okay, so this is the approach. And I think what's really exciting about this is that it allows the organizers to act with confidence, right? So what I'm showing you here is over time, how the number of conflicts in the system getting tracked is going down, right, over time. So that's good, of course. It's like, oh, whoa, you could use the system to resolve a lot of conflicts. But actually, I don't think that's the most interesting part about this diagram. What's really interesting is that, see these like pretty flattish areas? The organizers weren't working on the schedule doing nothing. Actually, they were improving the schedule in all the ways the system wasn't catching, but while doing so, not making the schedule worse for the things that the system does know about, right? That they could improve the schedule without adding additional conflicts, because the system would tell them if they made that move, hey, look, it's going to create all these other problems. So you got to think about it in a different way. Right? So I think the real power of the system is not only in how many conflicts it reduced, because at that point you could just say, oh, I ran the optimizer, all the conflicts I know about, I reduced all of them, right? But the real question is, well, how do we reduce the conflicts while still letting us apply our tacit knowledge and all the other things that we want to consider? Okay. So here's some of the outcomes from this project, right? We ran this at Chi and CSCW for a number of years. In one of the runs, we had an inclusive process that had 1,500 people involved in at least one aspect of the planning. It reduced the organizers' time from 100 hours to 5 hours. And the organizers produced better schedules, right? Not only by getting rid of these hidden conflicts, but also being able to advance the other planning goals that they have. And I think that's really where the power of the system comes from. Just one more slide and then I'll take your question. But just to go back to this idea of the computational ecosystem that we're thinking of, right? What the key ideas here is that we created a collaborative planning process that didn't focus on one group, that really thought about crowds, groups, and organizers all together. We were able to chain the contributions across the ecosystem to get better data. And moreover, we had this kind of mixed initiative interface that allowed the organizers to make informed decisions by taking together system intelligence, community input, and their tacit knowledge, and really being able to use all of that together. Right? And I think that's really where the power of the system comes from. But yes, please.
So one of the things that I noticed is that you start with, they are building this initial person, and then you reduce that by having the organizers making the final setup. I don't know if it's something that you're able to study or not, but how necessary is that reduction? Like the idea that at some point actually may not want to have still 1,500 people making this decision. Is there some kind of way in which some set of final decisions have to be made by a smaller group?
It's a great question, right? So I have a couple of thoughts on this. So one thought is, as someone who at the time was really interested in crowdsourcing, I was like, why don't we just let everyone plan the schedule together? Creates a lot of problems because if you think about who knows what, people could come in and be like, look, this is this is really good. Let's just make this swap. It's like, no. There's actually all these problems that are created, right? So I think that places a natural constraint on how many people can touch a schedule at one time. Okay, so the other thought, which is more political perhaps, but I think it also embeds something important, is that the organizers, they don't really want all their decisions about why they move certain things to be public. Why? Because they'll get a lot of complaints. It's like, hey, why did you do that? And they don't want to really have to explain themselves on every little decision that they make, right? And I think that idea, we could critique that and be like, well, that's not democratic enough. We need to, I actually think it's quite important to really design with, now it changes the structure of your community, of course, when you have that, but there is a sense in which it's complicated. There's a lot of things that you have to think about. A lot of people you have to please. You have sponsors as well. You have different things you have to think about. And really giving the organizers the tools that allows them to do that. And also, they're the ones who are going to want to use it, right? There's also this kind of question about adopting a process. But I think your question about, is there a fundamental limit on how many people can do it? I think there is. I don't know what the number is. But I also say that actually, even when we started, when we created those expert categories, that was actually in a room of about 50 people, right? So it's not that we were all open to thousands, because there was a time where we really wanted, because those were the ACs who reviewed all the papers. So they had the expert knowledge in terms of like, what were we getting this year? What were the themes that were emerging, right? So I think, the size thing is not only about, does it have to funnel down, but just at what stage and at what times, who are the people that you could engage and what would that be useful for? Right. So I think the consideration is not only the size of the funnel, but also just all the different choices we get to make in the process.
There are different processes to decide who's going to be
absolutely
making those final decisions, right?
Yeah.
Because you could imagine they are appointed, but you could also have a system in which they are elected or something.
Absolutely.
There is a lot of room for democracy and participation in how you design those things.
Absolutely. Right. And I think I'm simplifying a little bit because in one of the runs, some of the people we work with, the chairs were actually large screen display researchers. Like they had these it's like, I don't know, it's like the size of this room or something. It's just like a huge screen, right? And they had all these people working and collaborating with them. on their smaller independent devices, but suggesting things, and then they could see it on the big screen. So there's a lot of different patterns of collaboration that's possible. And I think what's exciting is that by really thinking more broadly like that, it gives us just more options, right? We're not so fixed in the way that we approach it. Yeah, please.
We had a question online who
yeah.
asked, how do you balance empowering the entire community in planning with cognitive overload of individuals who might just want to be responsible for specific niches?
Yeah, and maybe I just didn't make that point clear enough, but in terms of when people make contributions, it's always about the stuff that's important to them, right? And that's actually the whole point of doing the incentive chaining and being able to have, for example, a very well-curated list of papers for the authors and attendees to look at. So they don't have to look at the whole list of the stuff that's not relevant to them, right? So the thinking is, how do you design each of those interactions to be good for those specific ecosystem participants, but maybe have the other interactions be able to help make those other interactions better, right? So really thinking about the kind of crossover effects, but absolutely, right? You don't want to overload. And that's a lot of what we were able to solve for, is to not overload. If you just assume everyone's going to look at everything, then you could solve any problem, right? But that's not how we did it. Okay, good. I think I'm going to continue, but if you have more questions, let me know. But I want to switch gears and talk a little bit about this question of cultivating self-directed learners that we started with for scaling research training. Okay, and one of the first things I want to say here is that if you're really serious about this question, if you really want students to be independent researchers and to be self-directed, the students are going to need something that's called regulation skills. And what are regulation skills? They're cognitive, metacognitive, motivational, and emotional skills for just reaching a desired goal or outcome. Okay, and in independent research, well, you need this kind of skills to plan out your work, to plan out your research inquiry, but also to seek help in overcoming challenges, which is something that we found that sometimes the smarter our students are and the more accomplished they are, so to speak, the harder it is for them to ask for help because it makes them look dumb where they think it does. Okay, and these are the skills that students often lack, but if you lack them, in the current system, you just get constrained to root work. It's like, oh, you don't know how to do this? Well, we don't need you to plan. You just go transcribe the interview. I'll do the planning, right? But that doesn't scale very well. But also, I think it creates this model where we somehow are under scaffolding, right? I'm really kind of drawing a critique to myself and to the faculty here, where it's like, we basically end up, we try, but then we end up with like, okay, you just go bang your head against the wall until you figure it out. Right? And now, while some perseverance is obviously important for research, I think we can do better. And I think we can do better by really thinking about how could we do a better job of teaching and helping students learn these regulation skills that I'm talking about. Okay. So that's what we set out to do. So to address this challenge, we created a computational ecosystem into a model that we call Agile Research Studios. And it's a model for research training embedded in the learning community. Okay. And all students, regardless of how senior they are, so even like sophomore undergrads, they conduct independent research and they receive authentic research practice. And what I mean by that is that all of them go through a self-directed learning cycle of setting their goals, learning what they need to learn, planning out the research work, making progress, and then reflecting on their work and doing that over and over again. Okay, so this is going to be for everyone in the community. And as I mentioned in the very beginning, right, apprenticeship doesn't scale very well. And I think one thing we might be tempted to do is like, okay, well, let's just go hierarchical. Right? Just have the faculty mentor the grad students mentor the undergrads. But two problems. One is that the grad students are, still learning to become expert researchers. They're certainly not expert mentors yet. Okay, so that's one problem. And the other problem, partly as a consequence of that, the undergrads working under the grad students end up doing root work anyway. So not doing the self-directed kind of independent research work we're trying to go for, right? So that doesn't quite work. Okay, so the model we're going for in this ARS approach is a dispersed control model where what we're going to do to overcome this kind of one faculty to many student problem is that we're going to create these networks and interactions within those networks that's really going to help people learn, not only with the mentor, but with the community as a whole. Okay, so how do we do that? Well, we do that by creating this ecosystem that has its own, again, processes, social structures, and tools that work well together, right? So what are these? Well, so first of all, ARS adapts agile processes. So you might have heard about agile software development or agile design, right? But we take those kinds of approaches to scaffold the self-directed learning cycle so that the students are working agile, but towards a research goal. And I'll get into a little bit what that looks like. And then we have these social structures that support students planning research work and also getting help within the supportive community. And then we have all these tools, these virtual studio tools that support learning through the agile process and that promote the effective interactions within these communities, right? So really having these three parts, again, working together to do this. So I won't have time to get into all the details of this ecosystem, but I want to show you a couple of vertical slices of how processes, social structures, and tools work together, okay? So I want to first talk about planning. And as I was saying, students are going to plan their own research work. So they go through a 2-week sprint plan every 2 weeks where they set the goals for what they're going to do. And if you're familiar with Agile in software development or design, it's often like, my story or deliverable is like a MVP or like a simple version of this prototype. But here it's a little different. The goal is not so much building a prototype. It could be, but it's really what is a part of your research that's risky that you don't understand yet? And what is something you could do so that you could deliver on that understanding, right? So it's thinking more agile about the building of knowledge, not the building of products, okay? So we do that. But to support that, because planning is really hard, we have these SIG meetings, which are meetings where mentors, graduate students and faculty, meet with students who are working in similar research areas, and they get coaching on their plans, right? So the mentors and the coaches don't plan for the student per se. They are coaching the students to learn how to plan effectively. And the faculty are training the grad students and so on and so forth as well in that. And then we have a set of tools, one of which is the sprint log, where students not only record what are the things that they're going to do, but it also asks them to think about what are roadblocks that could come up, what are the deliverables going to look like, how long might certain things take, and when might they be over planning, and what can they do about that? So again, trying to help them think about planning, but also practice different planning skills as they do this, okay? So this is what a SIG meeting looks like, by the way, at least before the pandemic. This is what it looked like, where, right here, Bomani, one of my students, is presenting, and we're kind of paying attention to him and hearing what he has to say and giving him feedback on his plan, while, Jenny or just students are also playing with my dog, Stella, down there. I miss those days, by the way. We don't do as many in-person SIG meetings now. But some of us are, so that's good. Okay, so that's for sprint planning. And I just want to talk a little bit about help and collaboration as well. So a key idea, remember, right, I cannot be the single source of help. If I am the single source of help, we will never scale, right? So the help needs to be distributed. And one of the ways we do it is by having a studio meeting where everyone is coming together. And during that 3-hour period, one of the hours we spend doing something called pair research, where we pair up and help each other with whatever we need help with that week, okay? So let me just show you quickly what pair research looks like and how it works. So this is pair research. You go in there and you enter what you need help with. So I need help finalizing the intro to my talk, okay? And then you see what other people need help with and you rate how well you could help them. 5 is like, oh, I could totally help with that. 1 is like, I really can't. Okay, so I rate how well I could help, and other people are doing the same while I'm doing this. And we rate and we rate. We make pairs. Of course, confetti falls from the sky. Okay. And then we get pairings that maximally leverage the expertise we have within our community, right? Because we're going to find the maximum weighted matchings that actually pair the people who need help with the people who could best help them, taking into account the help resources that are actually available in the network, right? So if I'm the only one who could help this other person, that I'm likely to be paired with that person, but there's someone else who needs my help, but could also get help from somewhere else, that's more likely to happen, right? And then we also do certain things to make sure to promote new pairings, to promote new connections and stuff like that, okay? So this is pair research. And if you just use pair research and did this thing in studio with pair research, you're already like, oh my God, this is already giving so much help. It's already great. But again, thinking as an ecosystem, distributed help in our community is not just a single tool, okay? It's actually an entire ecosystem and culture of supports where, for example, students are learning over the shoulder with another student. There's Slack channels for getting help on different kinds of things. My undergrad started their own onboarding program for new students, right? So that every time there's a new student, they get paired with an onboarding mentor who meet with them weekly to just answer any questions they might have. It's the SIG meetings that we were talking about and the coaching they get, but it's also students reflecting every quarter. They do a 10-page self-reflection, no big deal, every quarter, where they reflect on how are they learning, and in particular, things like how are they collaborating, and how is help seeking happening, and are they getting help, right? And then we meet with the students one-on-one at the end of the quarter, not to talk about project progress, but to talk about their personal growth, right? And we talk about the issues that they might be having and the ways they want to grow, and that's what we end up working on. right? So it's all these things working together to get distributed help to happen. It's not just that one tool, okay? And with that, you can have some really spectacular outcomes. So in 8 years, we've had over 120 students now, 50 plus student research projects, the most undergrad research grants at Northwestern across any lab, lots of publications. This one's kind of embarrassing, but 40% of our undergrads end up at Apple, Google, Microsoft, or Facebook. Right? A little scary, but also kind of amazing. Like that's something I don't think gets replicated in other places. Just because they actually have the skills that people are looking for, right? They're actually learning how to regulate, how to do the metacognition, do the cognition. They're learning all of that, right? So it just makes them really attractive employees, okay? And then a lot of them start startups and do other things too. Okay, and then a lot of students stay in DTR for multiple quarters, and that really helps that learning over time, right? But really, like to me, and this is kind of one of the points of the talk, this doesn't matter. Okay, it matters, but this is really not what I'm excited about, right? What I'm excited about are things about, for example, students learning certain planning strategies. So actually learning how to build at appropriate fidelity, how to prioritize important things, sequence tasks, and move on despite uncertainty, because we have to do that at times that we don't know what to do, right? And I'm excited about students learning how to get help, and one of the things that happens is students helped more than 1/3 of their studio each quarter, which is a lot of help, right? So if you look at this graph on the right, what I'm showing you is the help network from a single quarter in DTR. And every node is a student. The colors indicate students working the same research area or the same SIG. And what you can see is there's a lot of help giving within the SIGs, but also across SIGs, right? So you're really getting distributed help across the community. And even more impressive than that, to me, it's this kind of thing, right? So when a student says, I can ask for help and that everyone asks for help, it doesn't make them stupid to need help, right? When students, this was a student who came in actually being very resistant about getting help, right? They think they had to do everything on their own. And I think along those lines, those skills are great, but I think it goes even beyond that. Okay, so here's a note from a student who said, thank you so much for teaching me how to advocate for myself and my ideas, embrace failure and inexperience, and search for truth rather than bullshit. Okay, so I think partly, what I'm trying to show you here is this idea that there's a lot of things that we could do that really advance the kind of values we care about and help students grow in the ways we care about. But I could never have done that as a single faculty mentor, at least not at the scale that I wanted to do it at, right? So if we think back to this computational ecosystem kind of picture, what we did here is create an ecosystem that allows us to develop regulation skills for planning, help seeking. But really what it's able to do is it's able to extend and scale the scale and the capacity of the community to produce and learn in a way that I never could by myself, right? And that's really when you start seeing the power of designing the whole ecosystem, is when you could get to these kinds of outcomes. Okay. So just real quickly, any questions about this segment so far? Okay, I think go ahead, I'll take one, yeah. Both. So like, for example, Kapil and Ryan, they lead their own SIGs now. So I'm out of their way. Well, I'm out of their way in their SIGs, but they're still learning how to coach with me every week. We do that on Fridays. And they get, how many years was that in your SIG for? 3, 4? That's right. So there's kind of 3, 4 years of training until they're comfortable. But by the time they graduate, they would have mentored 15 to 20 students. Right? They would have ran a small research lab already. So that's kind of the difference too, in terms of the training we provide for grad students, how that comes. Yeah. Great question. Any other questions? Okay, so I'm gonna move on a little bit. I might have to make some strategic choices for time, but let's see how far we get, and then we'll talk, okay? So I do wanna just share with you quickly some of the ideas for what's coming next. And the first one is really thinking about what I call ecosystem level intelligence, right? So I've been showing you a lot about designing these ecosystems, getting all the pieces to work together. But one of the things that happens, right? If you just think about your work tools, right? You got Slack, you got all these different tools, they don't talk to each other, right? That while we could design the ecosystem to have all the pieces that work well together, we don't really have a layer of intelligence that kind of sits above that. They can kind of know and help us and facilitate interactions across tools, across meetings, across structures. Right? So to do that, we're thinking about creating new technologies that can coordinate these kind of ecosystem activities. And one of the examples is work by Kapil here, network orchestration technologies. Okay, so what I'm showing you here is a note-taking tool. It's like, why am I showing you a note-taking tool? Okay, so it's a note-taking tool for mentors to take notes during one of those SIG meetings to just try to help think about what does my student actually need, okay? But actually, it's a little more than a note-taking tool. So it has a couple of special features, okay? One of the features it has is that there's a whole set of scripts running in the background that alerts the mentors and automatically fills in things that they might want to attend to with the student. Where does that come from? It comes from the students' interactions with the ecosystem across the week. So things like the students really struggling with this task, this took way longer than they thought, they haven't got help in a while. They, when they reflected, really wanted to get help on this, but they were never able to find someone to help them, okay? So a system is looking across and tracing and instrumenting different ecosystem interactions and pulling that information into a meeting to help mentors and to help students. And furthermore, as mentors figure out this plan for follow-up, oh, by the way, I never told you guys what SOAP is. So SOAP is a note-taking format that clinicians use. So like your doctors take SOAP notes when you go to the doctor. They talk about like, what are you reporting as your subjective needs? What are they seeing from the tests, right? What's their assessment of the situation? So we kind of adopted that format for note-taking, but again, with these kind of components where the system is instrumenting, but also when someone has a plan for follow-up, that plan for follow-up can go to later meetings. So for example, we might know that the student needs help on this when they go to the studio meeting, the community-wide meeting later in the week. And the system can kind of alert them or remind them of that or keep track of that to support them in that interaction, right? So what I'm showing you here is that it seems simple, but it's actually incredibly complex to create a technology like this that can actually monitor and facilitate across all these different tools and ecosystem interactions. But once you have it, it has a tremendous amount of power because now the abstractions that you're thinking about are at the level of the processes, the social structures and tools, and you kind of work across those, okay? So you just get a lot of power from this kind of thinking. The second thing I want to talk about is this idea that I call interactional intelligence, okay? So the idea here is that it'd be really nice if we're going to have an ecosystem and people are interacting within it for our systems to have an understanding of what's a good time for people to interact, should they interact at all? And if so, what are good interactions that would actually facilitate them connecting or whatever it is that we're trying to get out of those interactions, okay? So I have a fun example here. This is work by Ryan Louie, one of my PhD students, called opportunistic collective experiences, okay? And what these are is opportunistic collective experiences are computer programs that find moments in our day for us to connect with a friend or a loved one who is not living with us, right? Who's remote or in a different country, different state, whatever, okay? And in this example on the left, we're doing puddle feet. So we're both stepping in puddles together and sticking our feet out. And on the right, it's grocery buddies, right? I don't know, it's like an avocado lime mix, okay? And these things turned out to be pretty connecting, but the real question is, well, how does the computer even know when we could do puddle feet, right? What does the computer need to know to do that? And it turns out that actually computers have a really bad understanding of things like this. So in the example I have on the left, it's just this idea of grabbing food on a cold day, right? Or sharing a warm meal on a cold day, a very human idea. Computers don't really understand that, right? They could tell you if you ask on Yelp, like, give me a restaurant with soup or give me a restaurant that has spicy food, right? But it doesn't really understand this idea of human comfort, of needing warmth on a cold day, right? But what we're doing is we're thinking about creating these expression tools that allows us to define these interactional opportunities, essentially bridging from the human understanding of the human situation to something that the computer can actually detect with the kind of context features that it has, okay? And on the right, there's something about execution, but just real quick, high five. Okay, you guys are awesome. You guys suck. No, sorry, but like, doesn't it suck to like be left hanging? You know what I mean? Like, it's like super awkward, right? But this could come up too in these interactions, right? Because they're opportunistic and someone comes up and is like, hey, cheers, right? Because they're trying to have a beer at 2 p.m. and then other friends drink in the afternoon. So then they just are left hanging for a long time, right? So part of the thinking is that if we're really gonna have these ecosystem interactions be able to happen opportunistically, our system needs to be aware of the interactional resources that are available and kind of plan around that and think about these things, even though they're opportunistic. This is maybe a theme to kind of think about too, kind of this, it's planned, but it's also opportunistic, or it's opportunistic, but there's also some intelligence behind it to make it work. Okay, and all this just adds up to this picture for ecosystem level thinking where, I started by telling you about designing jointly all these different pieces together and the value of that. And now what I'm arguing in what's coming next is that we're gonna need intelligence at this higher level to support ecosystem functions and activities, okay? And that this kind of ecosystem thinking, I thought will be important, but really is, right? This is what we need right now for developing scalable solutions to a range of problems that we're thinking about, right? So we have to start thinking about ecosystem level problems that come up. Okay, so in just the last few minutes that I have, I want to very quickly make 2 points about the limited role of technology for advancing human values at scale. Okay, so I don't know if these points will be controversial or not. I'm actually somewhat hoping they will be, but let's talk about them. Okay, so the first one is that digital computers are inefficient for advancing human values, and the second one is that scaling amplifies compromises. Okay, so let me just start with the first one. So as a first point, I think we need to understand the limits of computing technologies if we're ever going to transcend them, right? We have to know what's computable and what's not, okay? And fundamentally, what computers are input-output machines, okay? What are input-output machines good for? They're really good at reliably producing desired consequential outcomes, right? You give it this input, assuming there's no bug in the code, this outcome happens, right? That's great. And that's not terrible. And it's useful for a whole bunch of things because we could automate things, we can make things more efficient. Okay, all those things are really good. But actually, over my sabbatical in the last 2 years, I've been really thinking about this more deeply and learning that really there's more to advancing human values than achieving these desired outcomes. Okay, and so this is a quote from Talbot Brewer from his book Retrieval of Ethics. He's a philosophy professor at University of Virginia. And he writes, this suggests a certain diagnosis of the modern mania, not a good term, that perceives the point of a life's work as some set of listable accomplishments, the point of parenting and the production of children with desired characteristics and capabilities, and the point of intimate relationships in some status to whose production and stabilization the participants ought to commit themselves. This outlook is a formula for indefinitely postponing the good life by dint of a ceaseless, determined pursuit of its static simulacrum. Okay. This is pretty harsh words, right? But I think what he's pointing out is that we have to be a little careful that, getting a long CV or having a lot of followers isn't necessarily the same as leading the good life, even though it's very productive, right, in some ways. And I think one of the rabbit holes that I kind of went down in this with my sabbatical is I started studying these people who foster self-direction. Okay, and what do I mean by self-direction? Broadly, you could think about it as helping people be more themselves, but I'll explain a little bit more. But what I did was I interviewed child development experts, therapists, counselors, yoga meditation teachers, art, music, dance teachers, entrepreneur coaches, intimacy coaches, and in particular, people of this sort who were using their vehicles as, using their professions as a vehicle for self-direction. So what I mean by that, for example, the art teacher I talked about wasn't really trying to help kids make art that looks good, but really think about art making as a process of engagement between self and other, or self and object. Right? So helping students and kids kind of having that kind of experience. Right? And these are some of the things that they said they wanted for the people they were working with. So to be authentic without alienating other people, to be open to other people's influence, and to be open to discovering things about ourselves, to persist under peer pressure, to continue on a lonely act, like playing the piano while all your friends are out there playing sports, to erase the shame from social messaging, not shove our feelings down, and to stop pretending. Okay. And I think the reason I'm sharing this is that the more I talk to these people, the more I realize that computers can't do any of these things, right? And in particular, the way these people were doing these things was that they create spaces, they lessen, they in some ways do the opposite of conditioning and programming, right? They somehow allow some of that to dissolve and for the person to find, in cases, another path, right? And the claim that I want to make from some of these points is that, well, if it's the case that being a consequentialist and thinking only about outcomes doesn't get you all the way to human values, then a computer, which basically encodes this consequentialist way of thinking, of turning inputs reliably into outputs, isn't going to either, right? That if the computer is going to be useful, that's great, but it's not going to be the in and end all for promoting human values, for advancing them. It's just not going to happen, right? Architecturally, it won't work. Right. And that in some ways to me is a little bit scary because, again, I'm a computer scientist by training. But also I think it's when we understand the limits of what computers can and cannot do that allows us to be more thoughtful about how we approach the problems. Right. So I actually think being more kind of aware and having that clarity about the limitations of the computer might be actually ultimately what we need to move forward than thinking they could just solve our problems. Okay. And lastly, I just want to make this point that scaling amplifies compromises. Okay, so this is a book from a short story actually from 1909. Okay, where in the story called "The Machine Stops" by E.M. Foster, he kind of predicted everything we have right now. There's social media in this story. There's video conferencing. All the tools we have is in this story, okay? 1909, okay? And now the story reads a lot at first, like the technological golden age we have today, but it's really a story about what we give up when we start thinking that something good enough has been accepted and that the machine may progress and the machine may progress and the machine may progress to eternity, okay? And there's this quote or this line very early in the story where the child is talking to his mother, trying to get his mother to come visit him, and she just won't because she's like, I can see you on the screen. Why do I need to visit you? Okay, and he says, the machine is much, but it's not everything. I see something like you in this plate, but I do not see you. I hear something like you through this telephone, but I do not hear you. That is why I want you to come, pay me a visit so we can meet face to face and talk about the hopes that are in my mind. Okay, and I think some of the thinking is not that scaling is so like terrible, but when we scale, are we really scaling the things that we want to scale? And what are we losing while we're doing it, right? So just having that consciousness about that. And the kind of question I want to leave you with is, look, if you have the values you want to scale on one side, and you have the technological solutions on the other side, if they perfectly overlap, I have nothing to say to you. You're living in happy land, okay? Everything's great. But for most of us, it doesn't exactly align. So what do we do, right? And one of the things that's really tempting to do is just to adopt technological values, right? Just to say, oh, actually, that's what I wanted in the first place. Like that's the kind of connection I like. That's great. But I think we'll all lose something if we compromise on the core parts of the human experience and what we actually want humanity to be, other than just what computers or what technology can already do. Okay. So then instead, if we're gonna not move and stick with our values, what do we have to do? Well, I think we have to be humble, first of all, because we don't know how to do it. That's what we started with. And then we just have to stick with it and see how far we can get, knowing all the limitations that we have with the technologies that we have, right? So really, I think to end this talk, I just would like to say that I think it's helpful for us to be mindful of our values, to actually accept the limits of technology, and then just to very patiently, little by little, learn how to scale, right? I would love to do my DTR program with tons more students. I don't know how. So I just have to be patient, and we just have to do the best we can. Okay, and I think computational ecosystems is one of the ways that could help us get there, because it's thinking about us embedded in an ecology, and it's also bring our machine and human capabilities to bear in one integrated ecosystem. Okay, so thank you guys so much, and I just want to, thank you. I'll just end there. Thanks. And I do just want to quickly acknowledge some of my awesome collaborators on the Kobe project, and then within DTR on some of the projects we're working on, including work by Capel and Ryan here as well. Okay, and then I'm one of the co-PIs of the Delta Lab. We are from learning sciences, design, and computer science, and all these different areas, and we sit together. We're across schools, but we sit together and we have a lab together, and that's really what allowed us to do the kind of work that I'm showing you today. Okay, so yeah, just thanks again. There's some links if there's things you want to follow, things that you're interested in. We're also about to release a movie on DTR. You could go to forward.movie and you find some information about that, but we'll release it soonish. Okay, so thank you all so much.
Hi, thanks so much for a great talk. That was really, really exciting. I have a question about the conference design tool.
Sure, yeah.
And have you thought about how designing conferences creates connections and then potentially collaborations between the people who might be assigned to the same sessions or the attendees who put that in their schedule?
Yeah, so a little bit, and some of our collaborators have done more work on that. They really, they created this tool called Confer, which was thinking as much about the conference schedule and all that, who are the people who can or should meet up at conferences. And I think a lot of the same ideas, if you could get that kind of information and your systems can help people find those connections, you could do it, right? Now, I happen to also think that the conference model maybe isn't the best model for connecting, where we, sit in our chairs for most of the conference and have very little time to socialize in comparison. So, some of the conference model might change as well to accommodate that in addition to just the tools, right? But yeah, no, that's a great point. That's important.
Thanks.
I just have a comment. I think this was a really, really special talk, and a talk that is given very rarely. One about thinking deeply about what you are doing and why you are doing and why you want to do it. And I'm incredibly grateful to Haoqi for coming and talking to us, because this is the things that make collaboration and intellectual exploration really, really rewarding. And so I didn't want to go without acknowledging that, because it has been really, really outstanding.
Thanks
so much.
Yeah, thank you. Thank you for being such a wonderful audience. It's some of the stuff for me, at least, is scary to talk about, because what the hell am I doing talking about human values, right? When I'm supposed to be a computer scientist. But like I said in the beginning of the talk, I can't sit well with myself when I can't align my work with the stuff that I actually care about. So it's maybe out of my hands, but yeah, thank you. Just thank you for being such a gracious audience. I'll stick around for a little bit if anyone wants to talk. Thank you for coming. Thanks, Luis. Appreciate it.